What is up, guys? In this video I thought I would talk about car mechanics and chemical engineering. And if you watch my YouTube channel or what videos I make, it probably seems pretty weird to see me making car mechanic repair how-to videos and then chemi lectures. And I really wanted to take a moment to describe why I like car mechanics as much as I do, especially after getting my degree as a chemical engineer and the professional certifications and all that. And to me, at a high level, I see chemical engineering in cars. And when you're analyzing a car that's idling, or when you're on the freeway and you're looking at an internal combustion engine, it is essentially just a reactor. It's like a CSTR that you would be studying in class. These are continuous processes that are occurring, and like with any process, we're going to be generating data and we're going to be tuning our system for an appropriate environment. So when you're on the freeway and you're just cruising along, your engine doesn't need to be revving that high, so you can tune down the RPMs and not give it as much gas. And it's all relating back to just chemical processes and how we're manipulating and predicting these processes. And when you start getting into diagnosing car problems, having a chemi background for me helps with this stuff, because everything here is just logical, and there's things you can do to troubleshoot it by just checking voltages on your sensors to make sure your sensors are good. And to give a great example of a problem that I am currently trying to fix on my cheap car is bad O2 sensor. And the oxygen sensor is downstream of your engine, and the purpose of it is to provide feedback to your engine control module or engine control unit. They're both the same thing. And what the ECU does is, based on the oxygen that is present in the exhaust of your reactor or engine, it's going to adjust the amount of fuel that it's spitting into your air fuel mixture. And so if you have a very low concentration of oxygen within your air fuel mixture, that means that there's way too much fuel, and therefore your ECM will tell the injectors to dampen the amount of fuel that they are putting into the intake. And so this ties right into process control that you learn as a chemical engineer when we have set points. And in this case, these set points are probably going to come from the EPA, trying to regulate what kind of tailpipe emissions we can have. Our inputs in this case would be O2 concentration of your exhaust, and then our outputs are going to be the air fuel mixture that actually goes into your engine. And so this is exactly what we talked about in Berkeley in the class called 160, which was our introduction to process control. And so another thing that I really enjoy about this stuff is that when you begin to work as a chemical engineer and you go on to a company, you're going to come across things called PLCs, and these are called Programmable Logic Controllers. These are used a lot in automation. And so if you are a biotech company trying to make some drug to save patients' lives, you're basically going to be running batch reactors, and you're going to be pitching yeast, although it's usually not yeast. You'll have some kind of eukaryotic cell line that's been specially modified for this purpose. But at the end of the day, you're going to be having a bunch of data points that create data, and you're going to be sending that to some kind of programmable logic controller to respond to that data. And this is exactly analogous to what we find in cars with the engine control units. It's just, you've got all of your inputs from your O2 sensors, your coolant sensors, your mass airflow sensors. All of this is feeding right into your ECU, and then your ECU will manipulate an output based on an input so that you can maintain a set point that the engineers who designed your car have already specified. And another thing that we talk a lot about with, especially in a chemical engineering process control class, is performance and robustness. And so when we're looking at cars, revving your engine really high will give you great performance, but you trade off your robustness because you're likely to blow a rod or something, or a piston. And so we come across the exact same physical restraints as chemical engineers when we're designing controllers, and we have to optimize either to have a very high performance system that will respond to errors very rapidly, or we can make systems that aren't as responsive, but they're a lot more reliable and they're able to handle bigger errors. And so that is another very key thing. The final thing I'd like to touch on, if you're interested in why I'm so interested in car mechanics as a chemical engineer, is at the end of the day, this all boils down to mass and energy balances. And this is the first class you take as a chemical engineer in college. You start talking about how we have conservation of mass and energy and momentum, and how like when you're looking at a car, you've got your air fuel, some gas and some oxygen going into your combustion chamber, and within the cylinder they're going to blow up, and you're going to generate some energy in the process. And that energy, some of it is translated into actually driving your car forward, and then a lot of it is also lost as heat. Usually it's about 2/3 is lost as heat. So your energy balance comes into play when you have to start talking about like radiator sizing and all that. So if your radiator blows up or stops working, your car is going to overheat because you can't dissipate all the additional energy that's being created. And all these things have set point temperature values. And so just simple intuition that you pick up as a chemical engineer applies directly to car mechanics. And at a small scale, it's really easy for you to kind of just get well versed in how everything ties together. And for me, it's pretty cool stuff that I really enjoy doing. And yeah, I hope you guys find this a little bit interesting. And thanks for watching.